Hi everyone and welcome to my channel. In this video, my topic is statistics and I'm really going to do the median, interquartile range, semi-interquartile range, cumulative frequency curves, and I'm doing this all for grouped data. This is really covered in math and it's done in Form 4 and sometimes in Form 5. So please stay tuned to see the rest of my video with my worked solutions. Now, as I mentioned in a previous video, in statistics, there are really two types of data. There's ungrouped and grouped. Ungrouped looks like this, where it's a specific mark or whatever detail they want to count, and their frequency for each one. And group data is when the categories are grouped, right? So they don't have it like 1, 2, 3, 4, 5 like this. They have it instead the group from 1 to 5 was the frequency of 1, and so on, right? Now, in this particular group data setting, 1 to 5 here is called a class interval. And in this class interval, there are two values. There's 1 and there's another value 5. 1 is actually called the lower class limit and 5 is called the upper class limit. So this could be written like this: 1 being the lower class limit, 5 being the upper class limit. Now similarly, each other class interval would have the same. For the class interval of 6 to 10, 6 is the lower class limit and 10 is the upper class limit, and so on. Now, in this group 1 to 5, there are many values. There could be values as low as 0.5 and as high as 5.5, because we always go 0.5 less than the lower class limit and 0.5 more than the upper class limit. So these two values, 0.5 and 5.5, have two other names. The 0.5 would actually be called the lower class boundary now, and the 5.5 will now be called the upper class boundary. So for each marked class interval, you would have a new lower class boundary and an upper class boundary, and some of them may overlap. Now I would like to move on to the note that I have on how to actually find the median given grouped data. Now, once we are given group data and we're asked to find the median, then we would need to plot the cumulative frequency curve, right? So what this means is that we are going to plot a curve using the same x and y axis that we use for all other graphs, right? So to do the curve now, we need to get some information. Now, these are the steps in getting that information. We need to have x and y values. So to get my x values, I need to know a few things. I need to add a column to the right, call it interval. And if I have words like no more than or more than, I'm going to put the upper class limit, right? However, if I have words like less than or at least, I'm going to use the upper class boundary. Now, when we follow the notes, and down here now tells us information on IQR and SIQR, right? You will see exactly how to do it. Now, the best way for me to explain is with an example. So let me do that now. This is example 1. It says a sample of 60 bulbs were tested and this was determined how long they lasted in hours, right? So the hours here is 90 to 99 was 1 bulb lasted that amount of hours. 100 to 109 was 2 bulbs, etc. Now this is group data, as we can see. And we are asked to construct a cumulative frequency table and a cumulative frequency curve. So nice. But however, before we start anything, we must look for these keywords. Are we seeing the words no more than, or are we seeing less than, or at least? So let's check through. I'm seeing no more than and more than. So nice. So that means I will go through part E. So I am going to, on the right here, I'm going to add a column, and I'm going to call that column interval right here. And I'm going to use the upper class limit for each one. So from 90 to 99, I'm going to use the upper class limit, which is 99. And I'm going to put less than or equal to. The other row, I'll put less than or equal to 109, less than or equal to 199, and so on. So this would now look like this. So now this new column would look like this. So that completes step 1. Now the next thing I need to do is step 2. I need to add another column to the right of interval and call it cumulative frequency. And I'm going to be adding all the other values from before. So I'm going to do that now. So this is what this column would now look like. Be 1, 3, 6, 11, etc. How did I get the 3? I added 1 and 2. How did I get the 6? I added the 1, 2, and so on. So this gives me this column here. So now I have completed step 2. So that takes me now to my next step, which is to do step, which is to go to graph paper and to use this as my x values and this column here as my y values. So now let me take you to that. Step 3 will then look like this. The x-axis will be here, and this would actually it represent the time in hours, right? Whereas the y-axis would be here, which would be the cumulative frequency. Now, from our column above, we know that the value 99 represented 1 in the cumulative frequency. So this point here is actually 99 and here is actually 1. This other point here is actually 109 and this corresponds here with the value 3 and so on. Now, I used an app to draw this graph. So that is how it came out like this with these values here, 100, 150, 200. But when you are doing it up manually, you will put 99 here, then you will put 109, you'll put 119, 129, 139, etc. going straight down to the last one, which will end up being 199. And these corresponding values, you will just mark it off accordingly, where you would have 60 at the top here, and you could break it up however, in counting fives or however, depending on your shape, right? So once this is done, this is our cumulative frequency curve. Now, of course, we have to connect the dots like this, and you try to go as smooth as you can, right? You don't want to draw straight lines or anything like that. It has to be like a stretched out S. So then we can go on to step 4, which is where we calculate the median from this curve. We are now finished with this step, and now we need to find the median. Now, even though they didn't ask for it here in our question, I'm still going to show you how to do it. The median now follows this formula, which is n plus 1 on 2, which turns out to be 60 plus 1 on 2, 61 on 2, 30.5. So looking at 30.5 on our graph, that'll be around here, and you come down here, and you'll get, say, about 150. So everybody, the median or Q2 is 150. So that takes care of this part. Now, I want to work out what are the interquartile range and the semi-interquartile range. But before I go into that, I want to just specify something. In some books, they say the median, which is Q2, is n plus 1 on 2. And in other books, they say Q2 is n on 2 when n is large. Now, they don't say what defines n as being large, if n is greater than 50, n is greater than 100 or so. So, if, say, you consider 60 to be large, then you could use 60 on 2 as your Q2, which is your 30 is the pointer value, and you will just read off the exact 30 value. However, if not, you'd use 61 on 2, right? Because you'd use the plus 1, and you would get the answer that we got before, right? Now, it doesn't matter. It all depends on your interpretation. Now, the next one I want to do is to find the IQR and the SIQR. The IQR is simply Q3 minus Q1. So that looks like this. And what is Q3 and what is Q1? Q3 is actually n plus 1, well, 3/4 of n plus 1 on 3/4 of n plus 1, and Q1, sorry, is 1/4 of n plus 1. Now, this is not giving me the exact Q3 value and the exact Q1 value. These are actually the pointers. So once I figure out what pointers these are, I go to the graph and get my actual values for Q3. So I will do that now. For Q3, I will end up getting the pointer being around 45.75 if I use the n plus 1. Now, the difference is negligible, right? The plus 1 or not. So when I come down here, I may get, say, about 165 or so. Now, for Q1, it will be n plus 1 divided by 4, which turns out the pointer ended up being 15.25. And looking at 15.25, that's around here. Come and reading off this value here, that may be about 135 or so. So then what is IQR, guys? It's 165 minus 135, which is 30. And SIQR is that value divided by 2. So semi-interquartile range will end up being 15 for the sum. Now, I know this part here never asked for those things, but because I was doing this example, I wanted to go through and make sure that you understand exactly how to find this. Now I want to go through these pieces quickly, A, B, and C. Now, to go for part A, they say, what is the number of bulbs, that stayed alight for no more than 149 hours? Now, 41 hours will have to come from here. So you will have to read off where is 141 around here. So that's probably around here. Now, of course, on your graph paper, it might be more accurate. So you come up to your graph, your cumulative frequency graph, and then you come across here and you read off here. So that turns out to be around 21 bulbs or so. So that is the answer for part E, because it says how many stayed alight for no more than 141. So 141 hours. And since this graph is the cumulative frequency graph, then if I go any further on the x-axis, it will be more than 141 hours. So if I want up to 141 hours, I have to take the answer as now 21 bulbs. So now let me go to part B. Now part B is phrased a little different. It says how many bulbs stayed alight for more than 165 hours. So what you need to do for part B is look for 165 here, so that's probably around here. Go up to your graph and read off that value. Now when you read off that value, you'll get probably around 48 bulbs, but that, guys, is not our answer. 48 bulbs represents the number of bulbs that stayed lit for up to 165 hours. But if the question is how many stayed lit for more than 165 hours, then it would not be the 48. It would actually be 60 minus 48. And why do we use 60? Because 60 is the total number of bulbs that were used in this experiment. So this, everyone, is the answer for part B. Now let me move on to part C. Now part C is a probability question, and for those of you who have never done probability, this is what you do. Probability is always measured as a fraction, and it's really the number of times an observation can occur divided by the total number of times of all other observations, right? So in this particular case, it said, what is the probability that a bulb chosen at random from the sample stayed alight for between 174 to 184 hours inclusive? What I should really do is find the number of bulbs that are lit for 174 hours and those that were lit for 184 hours, and then minus the two. So when I check my graph, 174 hours here, and reading across to the y-axis, I've got 53 bulbs. So this answer here gave me 53 bulbs. And when I checked for 184, when I came over here and checked for 184 and went back this way, I got 57 bulbs. So guys, the amount of bulbs that were actually lit between this period would actually be 57, take away 53. So that will end up being 4 bulbs. So the probability of this event occurring is the 4 bulbs over the total number of bulbs, as mentioned in the fraction before. So everyone, my final answer would be 4 on 60, which will end up being 1 on 50. So that, everyone, takes me to the end of this question. Now, I've kind of run out of time, so I will do another video where I do a second example where we use the other phrase. Okay? So please stay tuned for that, and feel free to share this, and I hope that you all have learned from it. Thanks, guys, for tuning in.